All right, ratios come up quite a bit in our lives. Really cool, really helpful stuff. Page 3 and page 4, loose leaf paper if you've run out of room on there. And create ratios based on related numbers. And then also be able to use ratios describing values of a missing value. So I'm going to start off just talking about ratios and how they interact. So if I've got a 1 to 2 ratio, for example, give you one apple and you give me two oranges, then that means that if you give me one apple, there'll be two oranges that you give me. If you give, or that, yes, if I give you two apples, then you'll have given me two and two, so four oranges. If I give you three apples, you'll give me two, two, and two, so six oranges. And you see that that's just how that goes, that it's just a repetitive nature in those ratios. So another way that you can see that is these different ratios being able to represent them in lowest number ratio. Okay, lowest whole number ratio. So that's going to come up a few times in chemistry, and I want to make sure that you know how to do that. So we've got 10 out of 20. The way that for me personally, I prefer seeing that as a fraction, so 10 out of 20, and then reduce that. Both of those you can divide by 10, and that'll give me 1 over 2. So that's a 1 to 2 ratio. Go ahead and try that second one. All right. So you should have 7 over 21. Divide both of those by 7. And you end up with 1 over 3. Okay. This next one, for me personally, a lot of times I will do things in parts, so 16 over 40. I don't see immediately what I can divide both of those by, but I do see that I can divide both of them by 4. I'm going to start with that and see where that gets me. So I've got 16 divided by 4 will be 4. That'll be over 10. 40 divided by 4 is 10. And then now I see that I can still divide both of those by 2. So then divide by 2, divide by 2. And that'll give me 2/5. So definitely, if you see that you can divide by a number, go ahead and do that, and then see if you can divide by another number because you want the lowest whole number ratio. And then if we've got 6/35, 6 can be divided by 2 or 3 or 6, and yeah, none of those numbers are also divisible by 35, so that's already in the lowest whole number ratio. So if you are a geometry person, you might see it this way. So in this situation, you've got the big triangle that is sides 1 to 1 to 1, but if you put these smaller triangles in here, then that's 3 sides per 3 sides per 3 sides, or as you keep going down, 9 to 9 to 9. That's another way to look at it, where you see similar triangles. Okay, so why that's important is there are going to be some times where you see things like this. This is actually a type of question that's like straight from the ACT. 6-foot man casts a 2-foot shadow. How big is the building that casts a 12-foot shadow? So huge, huge, huge thing here. Go ahead and draw a picture anytime you've got something like this. So I've got a person that's 6 feet tall and they are casting a 2-foot shadow. Then a larger building. I don't know how tall that is, but it is a 12-foot shadow. And then what you can do is you can do the shadow over the height. And that's how I'm structuring this ratio. So 2 over 6 for my first triangle equals Again, I'm shadow over height. So shadow is 12 over my height of x. Then, sorry, my headset cut off. Then I can do cross multiply. So I've got here 2x equals 6 times 12 is going to be 72. Divide by 2 to cancel out my 2. I've got to do that to both sides. And x equals 36 feet. Okay. If you were unsure about how I did that, you might want to jump back and check out the algebra video. Make sure that you are solid on those. Next, go ahead and try this one. 6-foot man casts 1-foot shadow. What size would the 32-foot high building cast? All right, we've got, again, draw a picture. 6-foot man. We've got a 1-foot shadow this time, and got 72-foot high building. I don't know the shadow size. Same thing for me. I always write out some sort of identifier. So shadow height or shadow over height equals shadow is 1 foot over 6 feet for the height equals shadow height, or shadow is x and height is 72 feet. Cross multiply, got 72 feet equals, multiply by the other, we've got 6 times x. Since this is multiplication, inverse operation is division, so divide by 6 on both sides. And I get x equals 12 feet. Okay. With that, we've got summary, reducing ratios to lowest whole numbers. That's a big, big deal. Understanding going back the other way if you needed to do that, and then comparative ratios, finding an unknown. Go ahead and try the ratios practice and let me know what questions you guys have.